The discriminant. So, the solution to x squared plus bx plus c is given by the quadratic formula, right? X is equal to negative b plus or minus the square root of b to the minus 4ac all over 2a. Did anybody ask their parents? Anybody remember the quadratic series? No, you didn't ask, did you? So here's the deal. This expression, b squared minus 4ac, right? It's under a root sign. So what does it have to be? What can you take the square root of? A positive number, maybe 0, right? What can't you take the square root of? A negative. So here's the deal. If b squared minus 4ac, is the deal down here? So b squared minus 4ac is going to tell us, do we have two distinct, right, or different real roots, right? 1, 2, or 1, 2. Do we have two equal real roots? Okay, this is what we mean by two equal, right? You really only get one value, right? But we call it two equal real roots. Or do we have two non-real roots, right? Because that's situation, right? We know this. So ignoring everything else, we've seen this before, right? We know we can have two roots, or one root, or no roots. Use the quadratic formula to solve each of the following. State the nature of the roots and determine the value of the discriminant. Okay, so we're going to solve, practice using the quadratic, which you've just been doing, right, recently. All right, so write out the formula. Actually, no. What are you going to do? Identify A, B, and C. Okay, so just state your A, B, and C. Write out the formula. I don't care if it's on the formula sheet, although you should probably copy it off of the formula sheet. Make sure that your fraction bar extends underneath the entire numerator, right, and over the, don't leave it off part way. Make sure that your root sign extends over the b squared minus 4ac. Okay, not like, you know, you're writing it part way and leaving it blank. So, you know, just make sure your notation is good. Substitute in, right? So negative b is going to be negative 6, plus or minus the square root. 6 squared. Always bracket the b. Okay? That way if you're putting a negative in there, you'll remember, hopefully, that when I square it, I'm going to get a positive. Minus 4 times a times c, all over, right? All over, so make sure that it extends, right? 2 times 1. All right, now you can work stuff out. So we've got negative 6 plus or minus square root. I'm going to show a little more detail. So 36 minus 32 over 2. So that's negative 6 plus or minus the square root of 4 over 2. All right, so it turns out this would have factored, right? How do I know it would have factored? Because I've got the square root of 4, which is 2. All right, so it doesn't matter at this point. Like if I said algebraically determine and you could have factored it, you don't have to go back and erase it all and say, oh, I could have factored it. You get to this point and you realize, oh, I could have factored it. Which actually means if you look at the discriminant, not only does it tell you the nature of the roots, which we are almost to discover, it'll also tell you if you could have factored it, right? Because if the discriminant, the thing under the radical sign actually is a perfect square, then you could factor it. Okay. Doesn't necessarily mean you're going to. Okay, so x is negative 6 plus or minus 2 over 2. That leads to two answers, right? Negative 6 plus 2 over 2, which is negative 4 over 2, which is negative 2. And x is equal to negative 6 minus 2 over 2, which is negative 4. So we have two answers, right? X is equal to negative 2, and x is equal to 4. So the nature of the roots, right? So here's what we're going to say. It's either two real distinct roots, two real equal roots, or two non-real roots. So what are these guys? Two distinct, right? Different, two distinct real roots. What's the value of the discriminant? Okay, what's the value of this? 4, right? So the discriminant is, so b squared minus 4ac. That's the discriminant, right? Which is 6 squared minus 4 times 1 times 8, which is 4. The discriminant's 4, right? We don't worry about the root sign here. We're just saying, what's the value of the thing, the expression that is under the radical sign? In this case, it's 4. Okay. Next. A is 1. B is 6. C is 9. X is equal to, yeah, I know, I just wrote it out, but I'm writing it out again. Now I'm going to substitute. What's the secret? Did I ever tell you the secret to math? Formula, substitution, answer. Right? The secret to math. So we got a formula, right? So we're going to determine, hey, we're going to use the quadratic formula. We're going to substitute values into that formula, okay, and we're going to work it out. All right, so what do we got? Negative 6, plus or minus, put the 6 in brackets, because if it's negative, you want to make sure there's brackets around it, so okay. Minus 4 times 1 times 9 over 2 times 1. So negative 6 plus or minus, so we got 36 minus 36 over 2. So negative 6 plus or minus the square root of 0 over 2. What's that equal to?
Negative 6.
Negative 6 over 2, or just negative 3, right? All right, what's the nature of the roots? How many roots do we have? 1. What do we actually say? 2 equal real roots. Okay, so 2 equal real roots. What's the value of the discriminant? B squared minus 4ac, right? 6 squared minus 4 times 1 times 9 is 0. Okay, all right. One more. X squared plus 6x plus 10. Same deal, right? I'm very systematic in the way I do things, right? I think, to do math, decently, just become very systematic, okay? So I'm going to write out the formula again. Yeah, I've written it out twice, but, don't get sloppy. And when you get sloppy is when you figure, oh, I've got it memorized, and you almost do, but you've got one thing wrong, right? Which means that the whole thing goes wrong. And we're just going to substitute negative b, negative 6 again. Square root b squared, okay, put the 6 in brackets, because it could be a negative 6, right? And we want to make sure we square properly. Minus 4 times 1 times 10 over 2 times 1. Okay? Now, if you look back and compare this to this, you know what A is, you know what B is, you know what C is, right? I mean, I can look back and say, all right, there's A is 1, there's C, there's A again is 1, oh, B is 6, and oh, we've got negative, that's negative B, so B must be 6. Good, all right. So X equals negative 6 plus or minus, okay, we got 36 minus 40 over 2. Now the fraction bar extends all the way, okay? Don't be sloppy. Negative 6 plus or minus the root of negative 4 over 2. All right, what's the problem with the root of negative 4? It doesn't exist, right? You can't do it. So what kind of roots do we have? 2 non-real, right? Because I can't work these out. Non-real roots. Okay, what's the value of the discriminant? All right, again, remember the discriminant is b squared minus 4ac, right? It's the expression that's under the radical sign, which in this case is 6 squared minus 4 times 1 times 10, which is negative 4. All right, what's next? All right, we good? So the value of the discriminant indicates the nature of the roots. If b squared minus 4ac is greater than 0, what do we have? 2 distinct, right? 2 different, 2 distinct real roots. If the value of the discriminant is equal to 0, what have we got? 2 equal real roots. And if the value of the discriminant is less than 0, we have two non-real roots. Okay? So let's back up and take a look. Why is this so? All right, so when it's positive, it has a square root. It will be added to negative b, giving you one number, and then divided by 2a. And it will be subtracted from negative b, giving you a different number, right? I mean, you can't add and subtract the same thing and get the same number. So you've got two distinct real roots. When it's 0, well, then it's basically gone, right? And you're just left with negative b over 2a, which gives you two equal real roots, right? This doesn't do anything, right? It's gone, right? So this effectively is just negative 6 over 2. When it's negative, you can't do the square root. So you can't do negative 6 plus the root of negative 4, right? So then there are no real roots, right? Which we could say two non-real roots. So it discriminates, right? It tells you the nature of the roots. When it's positive, I'm going to have two distinct real roots, right? Because I'm going to be adding a number onto something and then dividing by 2a. And I'm going to be subtracting that same number from something. Okay, so what do we do? State the nature of the roots. Well, we're going to have to write this in the form ax squared plus bx plus c equals 0, right? None of this works unless we're in that form. So we've got 9x squared is equal to 24x minus 32. But that's got to be equal to 0, right? So it's 9x squared minus 24x plus 32 is equal to 0. Now, is this asking us to solve? No, it's saying, what are the roots? So what do? We cut to the chase, right? First we should label A is 9, B is negative 24, C is 32. And I want to work out B squared minus 4AC. Okay, so we're just going to substitute. What's B? It's negative 24, and you're going to square that.
But it's about solving the equation.
I'm not solving the equation. Do you see me writing the quadratic formula there? Is there anything here that will lead to x equals?
No.
Okay, so we aren't solving, but we have to have a quadratic equation in order to figure out the nature of the roots, right? So we need to basically we got to figure out b squared minus 4ac, right? If it's greater than 0, we're going to say one thing. If it's equal to 0, we're going to say another thing. And if it's less than 0, we're going to say a third thing. So I got b squared minus 4 times 9 times 32. Okay, negative 24 squared is 576, right? Yeah. Okay, so 576. So, I want to move that over. Let's just write this. I'm going to go b squared minus 4ac is equal to, okay, so what do we got? 576 so 4 times 9 times 32 is 1,152. What's 576 minus 1152? Negative 576. What is the nature of the roots? Since b squared minus 4ac is less than 0, there are two non-real roots. Right? So the discriminant just tells us, don't bother trying to solve this, because there is no real solution. Right? It says, hey, you don't have to set up the full formula, because. All right, so just before we go on, let's just look at b squared minus 4ac. What do we know about b squared? It's always what? It's always positive. we are going to make our a value so it is what? Always positive, right? So we're going to change. So if our a value, if it's like negative 2a squared, since it's equal to 0, we're just going to go through, change all the signs, make it positive 2a squared. And here's the reason why, right? So we're going to make this always positive as well. So here's the deal. If c is negative, then, so this is always positive. We made a positive. If c is negative, what can we say about negative 4ac? It's going to be positive, right? So if c is less than 0, right? b squared, that's always positive. We have made a positive. So if c is less than 0, this is going to be plus, and you're going to be adding. You will always have two distinct real roots, right? B squared is always positive. We're going to make a, so it is positive. Then we look at it. So we say, hey, if c is negative, then I'm going minus a negative, which is plus. So if c is less than 0, we will end up with b squared minus 4ac greater than 0. Has to be, right? Positive plus, positive minus a negative, or positive plus a positive. If c is greater than 0 or equal to 0, well, if c is equal to 0, then b squared shouldn't, and b is not 0, right? Then we'll end up with a positive, right? So if c is equal to 0, it's just going to wipe out this term. If b exists, then we're going to have a b squared, which means we'll have a root, so it'll be real. If c is greater than 0, we don't know, right? It depends, right? So here, c was greater than 0, and we ended up with a larger number than this, so it could go either way, right? You actually have to work them out. If c is negative, you know it's going to solve, right? So if you're looking at 2a squared minus 17a minus 4, you can look at it and say, that's going to solve. I'm going to have two real roots, right? Since the c value is negative. So you can discriminate a little bit further, right, by looking at that. I mean, I wouldn't worry too much about it. You just plug it into b squared minus 4ac and work it out. Okay, so now we got two types of problems. Determine all the values of k if this has two distinct real roots. All right, how do I get two distinct real roots? What do I know must be true? I know that b squared minus 4ac must be what? Greater than 0. Okay, go back up here. What's a? 2. What's b? Negative 6. What's c? K. So we're going to plug in, and we have to solve for k, right? So we're being said, hey, what value can you put in here for c? What's that constant? So that I'm going to have two, well, we know if it's negative, but let's not go there yet. So we have negative 6 quantity squared minus 4 times 2 times k must be greater than 0, right? What's negative 6 quantity squared? 36, right? Everybody wants to say negative 36, I got to find a Nerf bat. Hit you over the head, right? We know this has to be. So 36, what's 4 times 2? 8. 36 minus 8k must be greater than 0. So negative 8k, I want my variable on the left-hand side, right? Because I want it to say like k is greater than or k is less than. So negative 8k is greater than what? Negative 36. So k, so what am I going to do? Divide this by negative 8. What do I do to this? Since you're dividing by a negative, you're going to flip the inequality. So k has to be less than 36, well, negative 36 over negative 8, right? Which we should reduce. So what's that? 18 over 4. Okay, so what's that? 9 over 2. So if k is less than 9/2, then this will have two distinct real roots. right? Any value of k less than 9/2. If it's equal to 9/2, what are we going to end up with?
2 equal roots.
2 equal real roots, right? Because if this is equal to 9/2, then this is going to be 36 minus 36, which will be equal to 0. And if it's greater than 9/2, then we're going to end up with 2 non-real roots, right? Because the discriminant will then be less than 0. Okay. So that's 1, right? And there's another one. The graph of y equals k plus 3x squared minus kx plus 1 has exactly one x-intercept. All right? What's the plan? So, George Collier, Hungarian mathematician, 50s, well, 4-step problem solving method, right? Understand, plan, do, and look back. Understand. All right, exactly one x-intercept. All right, it's got something to do with the intercept. So, plan. The plan is to figure out the value of the discriminant such that it is equal to 0. Okay, so I'm going to leave a little bit of space here. And I say, all right, we need b squared minus 4ac to be equal to 0. That's what tells me the nature of the root and tells me I have exactly one x-intercept. What's a? K plus 3. Bracket, right? Like in parentheses, actually. They're parentheses. What's b? Negative k. What's c? 1. So we just plug in, right? What's the secret to math? Formula, substitution, answer. Okay, there's our formula, right? We want exactly one x-intercept, right? We're going to sit there and say, how does that work? What is it that tells, oh yeah, that's that discriminant thing, right? It gives me the nature of the roots. All right, so what's b? Negative k. And I'm going to square that. Minus 4. So all you're doing is substituting, right? All right, what is negative k quantity squared? Positive k squared, right? K squared. All right, we're going to have to use distributive law, right? Forget the 1, it doesn't do anything, right? So we've got minus 4k, minus 12, and what does that have to be? Equal to 0. Okay, well, if we're nice to you, this should factor, right? Okay, 2 numbers above, yeah, it factors, right? So what do we got? K minus 6, k plus 2. Okay, I factored it. Now what do I always do after I factor?
Sure.
I check it. K squared plus 2 minus 6 is minus 4 minus 12, right? You're not going to blow the numbers, you're going to blow the signs, right? You're going to get the numbers wrong. Well, you might, because if you mess up the signs, then you get like 3 and 4 or something. But a very quick FOIL will let you know, right? And if this is wrong, then everything below that is wrong. All right, so we say what? K is equal to 6, or k is equal to negative 2. Understand? We know what we got to do. Plan. Oh, we got to get this discriminant equal to 0. Do. All right, we did it. Look back. Put the values in. So if k is equal to 6, we have 9x squared minus 6x plus 1 equals 0, right? B squared, so that's 36 minus 4 times 1 times 9. It's 36 minus 36 is 0. It's good. And if k is equal to negative 2, what do we got? Negative 2 plus 3 is 1, so we get x squared plus 2x, right, minus negative 2, so plus 2x plus 1 equals 0. That's the quadratic. B squared, 4, minus 4 times 1 times 1. 4 minus 4 is 0. It's all good. You don't show this, right? You can if you want. It's not going to deduct marks or anything. But this is the look back, right? You know, when you do that, when you're done the rest of the test, right? When you've finished everything off and you're looking, you say, okay, I got some time now. Let me just go back and check this. If k is 6, what happens? I get b squared minus 4ac equal to 0. Good. If k is negative 2, what happens? I get b squared minus 4ac is equal to 0. I should have full marks on that question, right? I showed some work. I solved it. Everything's good. Pretty much we're done, right? There's nothing after this. That's it? Good, because I hate going forward a page and then I have to delete a page and